everyone and welcome back to the video. Now that we have learned about expressions, terms, factors and its coefficient, we will now learn about the different types of expressions. So expressions on the basis of the number of terms can be classified into three broad categories. The first one is monomial, the second one is binomial and the third one is polynomial. So first we will discuss what is a monomial and a binomial. So monomial is an expression that contains only a single term. So all the expressions in which we have only a single term can be categorized as a monomial. For example, we have 4x squared. So this is an expression that contains only one term. So it is a monomial. Again we have 3xy minus 7z, 5xy squared, 10y minus 9 and 82 mnp. So all these expressions contains only a single term. So that can be known as a monomial. Now, what is a polynomial? So polynomial is that expression that contains exactly two terms. So if we have been given an expression and we calculate the number of terms and we find that the number of terms is 2. So what is that expression? That expression is a binomial. So a binomial has two terms in it. So let us take some examples. We have a plus b. We have two terms over here, a and b. So this expression is known as a binomial. Again we have 4l plus 5m. So here we have again two terms. So again this will be a binomial. Similarly, we have other examples of binomial as a plus 4, 5 minus 3xy and z square minus of 4y square. Now that we are done with binomial and monomial, let us know what is a trinomial. So a trinomial is an expression that contains exactly three terms. Just like triangle, in triangle we have three sides. So that is known as triangle. Over here we have trinomials. That means it is an expression that contains exactly three terms. So whenever we have been given an expression that contains three terms, so that expression will be known as a trinomial. Let us take some examples. Like we have over here a plus b plus c. How many terms are there? 3. So this expression is known as a trinomial. Again we have 2x plus 3y minus 5. Also this expression contains three terms, 2x, 3y and minus 5. So this is also an example of a trinomial. Again we have another example, x square y minus of xy square and plus y square. Again it has three terms, so it is again known as a trinomial. Now I will introduce you to a new term, that is polynomial. So what is a polynomial? A polynomial is an expression that contains one or more than one terms. But you will be asking that we have studied monomial, binomial, trinomial, so why polynomial? Polynomial is a broader category. Under polynomial, we have monomial, binomial and trinomial. But another important thing is that a necessary condition for a polynomial is that the power of the variable should be a non-negative integer. That means if I give an expression to you that is x to the power of minus 2, then it can never be a polynomial because the power of the variable x is minus 2, which is a negative integer. The power of the variable should always be a non-negative integer. That means it can be 1, 2, 3, 4, any of those things. It can even be 0 because if we have x to the power 0, that ultimately makes it 1. That is a constant term. A constant term can also be a polynomial. So the most important thing is that the power of the variable should be a non-negative integer in order to make that expression a polynomial. Now, a polynomial can contain any number of terms. It can be one or more. Like we have one term, then a polynomial will become a monomial. If we have two terms, so a polynomial having two terms is a binomial. If we have three, then it is a trinomial. And if we have more number of terms, in general, we can just call it as a polynomial. Let us take some examples. Okay, so we have an example over here, a plus b plus c plus d. How many terms are there? 4. So it is a polynomial. And we can see that these are the variables a, b, c and d. And the power of each of the variable is 1, which is a non-negative integer. Had it been a negative integer, then it wouldn't be a polynomial. Again, we have an example 3xy. It is a polynomial having a single term. That means it is also a monomial. Again, we have 7xyz minus 10. It is a polynomial with two terms. Okay, so it is a binomial. Again, we have a polynomial that is 2x plus 3y plus 7z. How many terms are there? 3. So what is it? It is a trinomial. Now let us check how much concept has gone into your brain. So we have a question over here. Classify the following polynomials as monomial, binomial and trinomial. That means we have to check whether the given polynomial is a monomial, binomial or trinomial. I have told you the definition of these things. So let us try these. The very first question is minus z plus 5. So the number of terms in this question is 2. So what will it be? Will it be a trinomial? No, it will be a binomial because it has two terms. So it is a binomial. Now again we have the second question as x plus y plus z. It has three terms. So it will be a trinomial. I am writing T for trinomial over here. Again we have y plus z plus 100. So it has three terms. So again it will be a trinomial. We have AB minus of AC. It has two terms. So it will again be a binomial. The fifth question is 17. It has just a single term. So it will be a monomial. So I am writing M for monomial. Now that we have learnt about monomial, binomial, trinomial and the various polynomials, so why not construct it? So over here, we have to construct three polynomials with only x as variable. So we have to keep this in mind that the variable can only be x, and using it, we have to construct three binomials. So initially, binomial means two terms. So we'll construct an expression of two terms with only x as variable. So the first one can be x square minus of 3. The second one can be, let's say, 2x plus of 9. And the third one can be 6 times x cubed plus of, let's say, 5 times x square. So in each and every example that we have constructed, we can observe that we have two terms. So it is a binomial and we have only used a single variable, that is x. In the next question, we have to again create binomials. But this time, we can use two variables. One is x and the other is y. So here, the possible binomials can be x plus y. Then we can write x square plus of 2 times of xy. And we can write x minus of 7y. So here we are using two variables x and y, and in each of these expressions we have exactly two terms. So these are binomials, and you can construct any sort of binomial using any combination that you like. Okay. Next we have to create monomials. So what is a monomial? It has only a single term, and here we have been given the liberty of using both the variables, that is x and y. So we'll write the first term as 7x, and then another expression as 4 times of y, and we can write another expression as 6 times x, y. Now we have to create two polynomials with 4 or more terms. What does it mean? We have to create two polynomials with 4, or even we can take more number of terms. So let's say first time we are creating a polynomial with 4 terms. So it can be a plus b plus c plus of 2. So how many terms it has? 4. It has 4 terms and it is a polynomial. Again, we have to create another polynomial. So let us take 5 terms this time. So here we can write 3 times of x square plus 2 times x plus y plus 6 times of x into y and minus of 1. It has 6 terms. So we can take as many a number of terms as we can. So we are done with it. Now that Now that I have taught you terms, so now let's learn about like terms and unlike terms. So like terms are those terms that have the same variable and the power of the variable is also same. I will explain you with example. Let us take two different terms, that is, one is 7x squared and another term as 3x squared. In both these terms, we can see that the variable is same. Here also we have x and here also we have x. And the power to which the variable is raised in this one is x squared. That means x is raised to the power 2. And here also x is raised to the power 2. So what we conclude is that in this term, the variable and the power is same as the variable and the power of this term. So these two terms are like terms. But observe one thing. The numerical coefficient of this term is 7 and over here the numerical coefficient is 3. So will it be a like term? Yes, it will be a like term. So the numerical coefficient doesn't matter. They can have different numerical coefficient, but for two terms to be like term, the only necessary condition is the variable should be same and the power to which the variable is raised should also be same. So give me some more examples of like terms. Okay, so it can be like 3xy and we have 4xy. Both of them has the same variable xy and xy. But the coefficients are different. The numerical coefficient may vary, but the algebraic factor should remain the same. Now, let us discuss what are unlike terms. Unlike terms, nothing. It's just the opposite of like terms. That means the variable and the power to which the variables are raised will be different in both the terms. Then those two terms will be simply unlike terms. Now let's discuss some examples of like terms and unlike terms. So in this particular table, we have the like terms, that is 7x and minus 13x. So why these two terms are called like terms? Because the variable thing is same. Both of them has the same variable, that is x, and the power of the variable is 1 and over here also it is 1. But the numerical coefficients are different. So it hardly matters. The numerical coefficient can be anything, but the variable has to be same. The second example that we have over here is 5x squared and minus 9x squared. This means that they have same algebraic factor. The variable is same and the power to which the variable is raised is also same. So these two are also like terms. The next example we have is 7xy and minus 5yx. Now, you must be wondering that here we have xy, but here we have yx. But 5, like minus 5yx can also be written as minus 5xy. Because 2 into 3 is 6 and 3 into 2 is also 6. So x into y is same as y into x. So this will also be like term. Now talking about unlike terms, here we have 7x and here 7y. So are they like term? No, they aren't. They are unlike terms because the variable is different. Here we have x, but here we have y. Again we have 7x and 7xy. The variable is x over here and the variable is x into y. So they are unlike terms. Again over here we have 7x and 5x squared. You must be wondering that both of them have the same variable, that is x. So why they are grouped under unlike terms? They are unlike because here the power of x is 1, but here the power of x is 2. So they are unlike terms. Let us now try some more examples on like terms. Write two terms which are like 7xy. So the first question over here we have is 7 times xy. And we have to write two terms that are like to this term. So the criteria for like term is that the variable should be same. So the two terms can be 3xy and it can also be minus of 4 times xy. Again, question number 2 given over here is 4mn square. So we have to write like terms. So the like term will have the same variable, that is mn square. The constant, that is the numerical coefficient, can be any number. Let us take minus 2. So minus 2mn square is the like term of 4mn square. Another example can be, let's say 6mn square. The third question that we have is 2 times of L. So the possible like terms of 2L can be only the variable has to be same. Numerical coefficient can be any number. So let us take 6l and let us take another number as minus of 9l. So these two terms are like terms for 2l. Now that I have taught you some basics of algebraic expressions, let us try some operations on it. So first we'll start with addition and subtraction of algebraic expressions. Now, first we'll discuss addition of algebraic expressions. So the sum of two or more like terms is a like term with numerical coefficient equal to the sum of the numerical coefficient of the like terms. So what is it? Let me explain you in simple words. The first thing that you have to keep in mind is addition is only possible for like terms. The very first thing is addition is only possible for like terms. Now, how to do addition? What we will do is that, let us take an example. Like we have 2 times x, y. And we have another term that is 4 times x, y. And we need to add these two terms. So what we will do? The sum of these two like terms is equal to xy. We will just simply write the variable thing. And now the numerical coefficient of this answer, that is the sum of these two terms, will be equal to the sum of the numerical coefficient of the individual term. That means 4 plus 2, which gives us 6. So the answer will be 6 times xy. In the same way, we do the subtraction. That means the difference of two like terms is also a like term with a numerical coefficient that is equal to the difference of the numerical coefficient of the two terms. For example, let us do the subtraction of the same question. That is 4 times xy and minus of 2 times xy. So here 4xy and 2xy are two like terms and we are subtracting these two like terms. So the difference of these two like terms will also be a like term. What does that mean? That the difference will also be a like term means that it will also have the same variable. But the numerical coefficient will be equal to the difference of the numerical coefficients of the given terms. That means 4 minus of 2. That is 2xy. I hope it's clear. Now let us solve an example of adding two algebraic expressions. So the algebraic expressions are 7x square minus 4x plus 5 and 9x minus 10. The very first step is to write the first expression that has been given as it is. We will write 7x square minus 4x plus 5. But when we are writing the second expression that has been given to us, we have to keep one thing in mind, that the like term should be written below the like terms. For example, the first term of the second expression is 9x, which is a like term of minus 4x. So 9x should be written just below minus 4x. Again, we have another term that is minus 10 in the second expression. So it has to be written just below the like term of the first expression, that is plus 5. Now we will simply add this. So in order to add this, first we will add minus 10 plus 5. Minus 10 plus 5 gives us minus of 5. Now we have to add 9x minus 4. That is 5 of x. And the sign will be plus. Now 7x square has nothing in the bottom. That means 7x square plus 0. So it gives us ultimately 7 times x square. Now let us solve example 1 given over here. Here we have been given 3 algebraic expressions and we have to add them up. The first expression is 7xy plus 5z minus 3zx. So the very first step is to write the first expression given as it is. Now we will take the second algebraic expression, that is 4yz plus 9zx minus 4y. As I told you that each of the term has to be written exactly before the like term of the first expression. So over here we have 4yz. 4yz is a like term with 5yz. So plus 4yz needs to be written just below 5yz. Now the second term in this expression is plus 9zx. So it is a like term to minus 3zx. So we will be writing plus of 9zx just below minus 3zx. And the third term we have in this expression is minus 4y, which is not a like term to any of them. So we will write this minus 4y separately. Now, the third expression that has been given to us is minus 3xz. So minus 3xz can also be written as minus 3zx. And this minus 3zx is a like term to minus 3zx and plus 9zx. So we will be writing minus 3zx just below these terms. The second term is plus 5x. So plus 5x is again not a like term to any of these terms. So plus 5x can be written separately. Again we have minus 2xy. So minus 2xy is a like term to 7xy. So we will be writing minus of 2 times xy just below plus 7xy. Now we will just simply add them up. We'll draw a line and add them. So here we find that plus 5x has nothing to add up with it. So the answer will be plus 5x for this term. Again minus 4y has nothing to add up. So I will write minus 4y. Now in this line we have all the like terms. And as I told you, the sum of the like term is again a like term. So it is a like term. So the variable will be the same. It will be zx. Now we have to simply algebraically add the numerical coefficient. So we have minus of 3 plus of 9 and minus of 3. Minus 3 gives us minus 6 plus 9, which ultimately gives us plus of 3. So here we will have plus 3 times zx. Now here we have plus 5yz and plus 4yz. So again the sum of these two like terms will be a like term, that is yz, and the numerical coefficient will be equal to the sum of the numerical coefficient of these two terms, that is 5 plus 4, which gives us 9. Again here we have a like term 7xy and minus 2xy. So the difference will also be a like term, that is xy. And over here we have 7 minus 2, which gives us minus 5. So the answer will be it will be plus 5. 7 minus 2 gives us plus 5. Over here the answer that we get is plus 5xy plus 9yz plus 3zx minus 4y plus 5x. Now we will be solving an example of subtraction. So the expression given over here is 5x square minus 4y square plus 6y minus 3. And we have to subtract this from another expression 7x square minus 4xy plus 8y square plus 5x minus 3y. So remember, when we are subtracting and we have been given an expression and we have to subtract it from another expression, the expression which is after from has to be written first. So we have to write this expression first and then this expression. In order to write this expression, we will write 7x square minus of 4 times xy plus of 8 times of y square plus 5x minus of 3 times y. Now we have to subtract it from another expression. So we will write the other expression below it. But remember one thing, write the like terms below the like terms. The first term is 5x square. It is a like term with 7x square. So we will write 5x square below 7x square. The second term is minus 4y square. It is a like term with 8y square. So we will be writing over here minus 4 times of y square. We have plus 6y. It is a like term with minus 3y. So we will be writing plus 6y below it. And the last term is minus 3, which isn't a like term. So we will write minus 3 separately. Now we will draw a line. And in subtraction, there is a rule that we have to change the sign of each and every term of the bottom line. That is, the expression that we have written on the second needs to be changed. Needs to be changed in which aspect? We have to change the sign of each and every expression. For example, the first term has a positive sign. So we have to change the sign of the first term and make it negative. This term has a negative sign, so it will change to positive. Again, plus 6xy needs to be changed to minus 6xy, and plus 3 will be changed to, minus 3 will be changed to plus 3. Now, we will simply do the same as we did in the process of addition. So here we have plus 3 and it is adding up to 0. So we will write plus 3. Now, we have minus 3y and minus 6y. We know that the difference of two like terms or the sum of two like terms gives us a like term. So we will have a like term. So the variable will be y, and minus 3 minus 6 gives us minus of 9. Again, we have plus 5x. So as it is, we will write plus 5x because it isn't adding or subtracting to any other term. Over here, we have plus 4y square and plus 8y square. That means it gives us 8 plus 4, 12 times y square. Again, we have minus 4xy, which is not again operating with any of the terms. So we will simply write down minus 4xy. We have 7x square, which is subtracted with 5x square. 7 minus 5 gives us 2 times x square. So this expression is our final answer. That reads out 2x square minus 4xy plus 12y square plus 5x minus 9y plus 3. Now we will be doing something interesting. You all must have heard about rectangles. Okay, so rectangle has two dimensions, that is length and breadth. So in a rectangle, when we have to calculate the area of rectangle, the formula that we use is length multiplied by breadth. So over here, we have been given a table that we need to complete it. The table provides us with the length of the rectangle and the breadth of the rectangle, and we have to calculate the area of the rectangle. So first, we need to know the formula of area of a rectangle. We know that area of a rectangle is length multiplied by breadth. Here we have 3x as the length and breadth is given as 5y. So we have to multiply 3x along with 5y. So this gives us 3 into 5, that is 15, and x into y gives us xy. Now we have to multiply 9y with 4y square because we have to calculate the area. So in order to calculate the area, we'll multiply 9y with 4 times of y square. 9 into 4 gives us 36. And what about y square into y? Y square into y gives us y cube. Another example we have is the length is 4ab and the breadth is 5b square. So we have to multiply length into breadth, that is 4ab multiplied with 5 times of bc. We all know that 4 multiplied by 5 gives us 20. And when we multiply AB with BC, we get A. B into B gives us B square and C. Now we have to multiply 2L square M, 2 times L square M with 3 times L M square. Now 3 into 2 gives us 6. L square into L gives us L cube. And M square into M gives us M cube. So we are done with finding the area of rectangle. Now I will be teaching you to calculate the volume of a rectangular box. So first, let me tell you that a rectangular box is of cuboidal shape. So the volume of a cuboid is given by, we all know, it is length into breadth into height. So in this given table, we have been given with length, breadth and height, and we have to calculate the volume of the rectangular box, which is also known as a cuboid. So we will be multiplying these three terms. That means we will multiply the length, that is 2ax, with the breadth, that is 3 times of by, with the height, that is 5 times of cz. Now 2 into 3 gives us 6 and 6 multiplied by 5 gives us 30. We have ax multiplied by by multiplied by cz. So this will ultimately give us ABC x, y, z. because we don't have any like term over here. Now, we have length as m square n. So we'll write length as m square n. And we have to multiply it with the breadth, that is n square p. And the height given over here is p square n. So, what will be the volume? First of all, we have to multiply m square n with n square p with p square m. Here we have m square, here we have m. M square into m gives us m cube. Here we have n and here we have n square. This gives us n cube. Here we have p and here we have p square, which gives us p cube. So ultimately, the volume of this rectangular box will be m cube, n cube, p cube. Let us try another example, that is 2p as the length, 4q square as the breadth and 8q cube as the height. So the volume will be length, that is 2q, multiplied with breadth, that is 4q square, multiplied with height, that is 8q cube. So first we have to multiply the coefficients, that is 2 into 4 into 8. So 4 into 2 gives us 8 and 8 into 8 gives us 64. Here we have q into q square into q cube, which gives us q to the power of 6. So let me explain you this thing. Whenever we have q and then it is multiplied with q square and it is multiplied with q cube. So what happens is that the bases are same. So we have a rule that when bases are same, then the powers are added. Here the power is 1. So we'll add up the power, that is 1 plus 2 plus 3, which gives us q to the power of 6.